Okay, so I'm going to do this exam 1 review for Math 1613. There are 20 questions, so let's do them. First question is write the equation of a circle center 854 with radius 20. So in this problem, you have to know the equation of a circle, the standard equation, which is x minus h square plus y minus k square equal r square, where each k is the center of a circle and r stands for radius. So this is the equation of circle centered at hk and radius r. In this problem we have given the value of h and k. It's 5 and 4. So just plug 5 for h, 4 for k, 20 for r, and that will be our answer. So here our answer is x minus 5 square plus y minus 4 square equal 20 square. And that's all for problem 1. Okay, for problem 2, let's look at number 2. um, Here number 2, recall the equation for a circle with center hk. We know this is the equation of a circle with center at hk and radius r. At what point in the first quadrant does the line with the equation y equal 2.5x plus 5 intersect the circle with radius 3 and center 0, 5? So we have given a circle center at 0, 5 and radius is 3, so something like that. And now we need to find out there is a equation of line. There is a line y equal 2.5x plus 5. So let's say this is a line. We need to find out where this line intersect with this circle in first quadrant. So this is the point. We need to find out the coordinate of this point. So you can see that at what point in the first quadrant. So there might be two different points, but we are looking for this point which is on the first quadrant. So x coordinate and the y coordinate. So how we can find it? First of all, we have to write down the equation of circle using the formula we use for problem 1. X minus h is 0 in this case because the center is 0, 5. Y minus 5 square, the radius is 3 square. So that's the equation of circle. Now we need to find out the point where this circle intersects with this line. As you can see, the equation of line is y equal 2.5x plus 5. So when this line intersects with this circle, you can just plug y equal 2.5x plus 5 in this equation and solve for x. That gives us the x coordinate of that point. So let's do that. This is basically x squared plus, if we want to find out this point of intersection, we need to substitute y equal 2.5 x plus 5 here. So if I do that, 2.5 x plus 5 we're trying to find out the point of intersection of this circle and this line. That's why I'm plugging value of y in this equation of the circle. There is a plus 5 and minus 5. I can just cancel this out, and now it gives me x squared uh, the square of 2.5 x squared, which is basically 2.5 is 5 over 2. So square of 5 over 2 is 25 over 4 x squared equal 3 square means 9. If we try to simplify this, I have to make same denominator here. So if I do that, on the left side, 4 plus 25 is 29x squared over 4 equal 9. So our goal is to find the x coordinate. So let's multiply both sides by 4 over 29. So 4 over 29. By doing that, I can cancel this 4 and 4, this 29 and this 29. So x squared is 36 over 29. If you try to find the x coordinate, it would be, you will have two choices, plus and minus, but because we're looking for the points on the first quadrant, we ignore the minus value, so we just take the plus value. So 36 over 29. If you do that, it will be square root of 36 over 29 will be 1.11417. So I'm just going to use how many decimal places? 3 decimal places. So x would be 1.114. So that's the x coordinate of that point. After finding the x coordinate, I can find the y coordinate by plugging the value of x back in one of the equation, either in equation of circle or this line. I'm going to choose this line. Y equal 2.5, x is 1.114 plus 5. If I do that, the value of this y is 7.785. This is 3 decimal place. So the x coordinate and then y coordinate are, I'm going to put that value back here. After 3 decimal places, x coordinate is 1.114, y coordinate is 7.785. Okay, so basically it's a point of intersection between the circle and the line we have given. Okay, so let's go to the next problem. The next problem is convert the angle 420 to radian. So if you want to convert degree into radian, we know that 180 degree is equivalent to pi. So 1 degree is equal to pi over 180. So whenever you try to convert degree into radian, you have to multiply 420, that degree, by pi over 180. So we can change this degree to radian by multiplying this angle by pi over 180. So if we do that, just multiply this pi over 180, and it will be, I'm going to use my calculator to divide 420 by 180, and so they are asking us to put the answer in terms of pi. So my answer is 420 divided 180 is 2.33. So the answer, give the exact value and use pi for pi. So that means if you just cancel this 0 and 0, and 42 divided by 18 is 21 over 9, so 7 over 3 pi. Just divide 420 by 180, it's 7 over 3. So this is the exact answer. Exact means don't put the value of pi. Okay, so if you want to convert the degree into radian, you always have to multiply by pi over 180. And for the problem 4, you are trying to convert the radian into degree. You just have to do the opposite. You have to multiply by 180 by pi. So for this problem, just multiply it by 180 degree by pi. And if you do that, that will be just cancel out pi and pi. And 180 divided by 6 is 30. 30 times 5 is a 150 degree. Okay, so that's problem 4. Problem 5, the angle between 0 to 2 pi in radian, that is coterminal with the angle 20 over 7 pi in radian, is. So first of all, we have to understand the meaning of coterminal here. Okay, so coterminal means, let's say you have an angle theta. So let's try to draw angle theta. This is angle theta. This could be anywhere in the first quadrant, second quadrant, third quadrant, or fourth quadrant, anywhere. You know, for this angle theta, after making one complete rotation, another angle, which is 2 pi plus theta, has the same angle. So theta and theta plus 2 pi, they are called coterminal because they have the same line. No matter how many times you repeat that process. So theta plus 1 times 2 pi, 2 times 2 pi, 3 times 2 pi, so n times 2 pi. That's called coterminal because they share this line. So we need to find out between 0 to 2 pi what is the coterminal of 20 over 7 pi. So we need to find out how many 2 pi's are there. Okay, so 20 pi over 7 actually can be written as 14 pi plus 6 pi over 7. What I did is I just divide 20 into two parts, where one is the maximum number which can be divided by 7, and another one is the less than 7. So if you split this, it will give you 2 pi plus 6 pi over 7. So the coterminal angle for this one is actually something plus 2 pi times some integers, but here you can see that 6 pi over 7, let's say 6 pi over 7 is your theta. If you add 2 pi, then it will give you 20 pi over 7. That's why this 6 pi over 7 and 20 pi over 7 are coterminal angle. And remember, we need to find out something in between 0 to 2 pi. So 6 pi over 7 is less than 2 pi. So the coterminal angle for 20 over 7 pi is 6 pi over 7. So 6 pi over 7 is your answer. This is the answer. And to find out the coterminal angle from the given angle, what you can do is you can keep subtracting 2 pi until that angle becomes less than 2 pi. So from here, if you subtract 2 pi, then the first angle you are going to get is 6 pi over 7, which is less than 2 pi. If this angle was greater than 2 pi, you still keep subtracting 2 pi until you get an angle which is less than 2 pi. That would be your coterminal angle. Okay, that's problem 5. Let's go to problem 6. On a circle of radius 6 feet, what angle would subtend an arc of length 1 feet? So you have a circle, okay, and radius of this circle is 6 feet. That's the radius. And what angle? You need to find out the angle, this angle, such that the arc length, meaning this length, is 1 feet. To do this problem, we should know the formula. Um, and then formula for this one is, okay, so the formula for this one is, if you have, let's say this is your radius, this is your arc length S, then there is a formula called theta equal arc length over radius. But that angle will be in the radian. Okay, so for this problem, the value of theta is arc length, which is 1 feet over 6 feet, 1 over 6. This is in radian. But we are looking for the answer in degree, so we need to multiply this by 180 degree by pi. That's how we convert radian into degree. So basically that's 30 divided by pi, and if you divide 30 by pi, it will give you 9.549. In 3 decimal it would be 9.549 in degrees. Okay, so this is in radian. You have to convert that in degree, and you can convert the radian angle into degree by multiplying by 180 by pi. Okay, and use the calculator, just divide 30 by pi, and that will be your answer. Problem 7. A sector of a circle has a central angle of 30 degree. Find the area of the sector if the radius of the circle is 14 centimeter. So this is a circle, and there is a sector of a circle, this sector, let's say, and here is the angle 30 degree, it's given, and then radius of the circle is 14 centimeter. Now we want to find out the area of this 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 sector, this part. We want to find out the area of this part. Okay, for that we have to know the formula. So if, let's say this is angle theta, if this is angle theta, which is 30 degree in this case, then there is a formula, A equal theta over 360 degree pi r squared. That is the answer in, if theta is in degree. If theta is in degree. If theta is in radian, then this formula would be theta over 2 pi. Okay, but in this case, because theta is 30 degree, this is the formula we're going to use. So it's a 30 divided by 360 pi r square, means it's a 14 square. So if you use this formula, after simplification, the answer for this particular problem, number 7, would be 51.312. Okay, just use your calculator. 14 squared, that's what I'm going to do here. 30 divided by 360 times pi times 14 times 14. If I do that, it will give me 51.3126, and that's the area. So remember, the area is it's in the centimeter square, because the radius is centimeter, so it's in the centimeter square. This is the area. So the main part is you need to know this formula, which is the area of a sector, this sector. Okay, now for the problem 8, you have to once again you have to use the same, let me draw a picture here. Let's say this is a circle, and there is a central angle theta, there is a radius, there is a arc length, yes, then there are some formula we have to understand. The formula v, let's say this is the linear velocity, velocity is equal to s over time, which is the arc length by time, how how long it takes. Omega is the angular velocity equal theta over time. And there is a relation between the radius, which is radius, and the linear velocity over angular velocity. So the radius is equal to linear velocity over angular velocity. In this particular problem, we are looking for the angular velocity, so which is omega. So in terms of radius and linear velocity, omega, which is angular velocity, is r over v. That's the formula we're going to use. And there is another formula we need to use. That's for the second part, which is revolution per minute. So the revolution per minute, there is another formula for that. Um, revolutions per minute is equal to angular velocity over 2 pi. So these are the two formula we are going to use here. And also, so before we use the formula, we have to keep in mind our units should be same. For example, here we can see that the diameter. From the diameter you can find the radius r is 13. The diameter is 13 inches, means radius is half of the diameter, so radius is 18 inches. Because the radius is given in inch and we would like to find out the angular speed in radian per minute, the angular this is the linear velocity, 55 miles per hour. V is 55 miles per hour. So we need to change this mile into inch and hour into minute to make the same unit. And we can do that. Miles can be changed into inch by multiplying by 63,360, because 1 mile is equal to 63,360. So if you multiply this by 63,360, now it's going to be in inch. And because it's per hour, if you divide it by 60, now it will be inch per minute. For the minute, we divide by 60 because 1 hour means 60 minutes and 1 miles means 63,360 inches. So if you do that, if you multiply these two things and divide by 60, you are going to get I have to use the calculator here. 55 times 63360 divided by 60 is 58,000. Let me just 58,080. So that's the linear velocity in inch per minute. But we are looking for the angular velocity. If we go back here, this formula, angular velocity is equal to linear velocity over radius. I did a little bit mistake here. It should be linear velocity over radius. Okay, so if I use that formula here for this part, angular velocity is linear velocity, which is 58,080 divided by radius, which is 18. It gives me 3,226.667, and that's in radian per minute. So that's the answer for the first part. For the second part, the formula is revolution per minute is omega over 2 pi. Omega means angular velocity divided by 2 pi. So omega over 2 pi. So just use this value, 3,226.667 divided by 2 pi. If you divide it by 2 pi, it will give you 513.539. So for problem like it, you just have to use these two formula. Okay, so let's go to next problem, problem 9. So without using a calculator, compute the sine and cosine of 120 by using the reference angle. So for this problem, you have to understand the meaning of reference angle. Okay, so the reference angle is the angle made by that line, whatever angle we're talking here. In this case, it's 120 degree. If you draw that 120 degree, the so let me just draw this 120 degree here. So this is our coordinate system. If I try to draw 120 degree, this is 90, so 120 degree would be somewhere here. This is 120 degree. Okay, reference angle for this line means the angle made by this line with x-axis. And here you can see that this is the 120 is also made by this line with the x-axis, but there are two different options we have. One is this one, another one is this one. We always choose the smallest one. So you can see that if this is 120 degree, the reference angle for this line would be 60 degree, because 120 plus 60 is 180. So now to find out the value of trig function for 120 degree, we can also use the value of that same trig function for 60 degree. But you have to understand the value of any sine function, any trig function for this 120 degree would be either plus or minus of the very same trig function for the 60 degree. And for that, first of all, you have to understand where the sine function would be positive and where the quotient function, where the sine function is positive and where the sine function is negative. And you can always remember that thing by looking the graph of the sine function. So let me give you the graph of the sine function. So this is the graph of sine function. So this is pi, this is 0, this is 2 pi. As you can see, from 0 to pi, the sine value would be positive. So from first quadrant, in first quadrant and second quadrant, the sine value would be positive. So the meaning of that is sine 120 is equal to positive of sine 60, because there is a rule. That rule says sine theta is either plus or minus of sine reference angle for that theta. And based on the position of that reference angle, in this case it's the second position, but in the second position always sine would be positive. So that's why sine 120 is equal to positive of sine 60, and we know sine 60 means it's the square root of 3 over 2. So the answer for at least you have to know the trig function from 0 to 90. Like, what is the value of trig function for 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. And by using those reference angle, we can always find out for the the any angle which is greater than 90 degree as well. So in this case, you can see that sine 120 is actually is equal to sine 60, because 120 and 60 are reference angle and sine is positive on both quadrant by looking this graph. But what happens to the quotient function? So for that, we can also use the graph of the quotient function. This is the graph of the quotient function. So this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. So as you can see, from 0 to pi over 2 the cosine function is positive, but from pi over 2 to pi or 3 pi over 2 cosine function is negative. So that means the cosine function is positive on the first quadrant and the final fourth quadrant, and it's negative on second and third quadrant. So that means cosine of 120 degree is negative of cosine of the reference angle for 120 degree, which is 60 degree. So it's a negative of half, because cosine of 60 is half. So these are the two values. Okay, I'm trying to make it small. So sine 120 is square root of 3 over 2, square root of 3 over 2, and cosine 120 is negative half, and that can be possible because of the reference angle. The reference angle is 60 degree, and in what quadrant is that angle? It's on the second quadrant. By looking this graph, you can say that. Okay, so let's go to next problem. By using the very same fact, 2 pi over 3 is, again, it's a, it's 120 degree. If you try to see in degree, we can use the same fact and we can find out the value of cosine and sine 2 pi over 3. So by using the reference angle one more time, so 2 pi over 3 is, one more time, this is 2 pi over 3, and reference angle for 2 pi over 3 is pi over 3. So cosine 2 pi over 3 can be found by using negative of cosine pi over 3, because the reference angle is pi over 3, which is on the second quadrant, and for the cosine function in the second quadrant the value would be negative. So we take negative cosine pi over 3, which is negative half, and for this one it's sine pi over 3, okay, which is square root of 3 over 2. The very same problem, one is given in the degree and another one is given in the radian. It doesn't matter, we can always find this value using the reference angle. And as you know, you have to give the exact value here. Exact value means you cannot round this square root of 3, just use the square root of 3. Okay, so now problem 11, find an angle theta between 0 and 360 that has the same sine as 240. So we can use the same idea about the reference angle here. If we try to draw 240 degree here, 240 means it's a 180, this is 270, so 240 degree means somewhere here, right? But if you try to find out the reference angle for 240, which is this angle, this part, which is 80 plus 60, so this is 60 degree, so that's the reference angle. But as you can see, it's on the third quadrant, so sine value should be negative. So sine, you know if you want to find out the sine, another value, another angle which is same as the sine 240, then you can just, okay, so if we check here, so sine 240 has same value as negative sine 60, but we want to find out the theta for which sine 240 and that theta gives you the same value. So for that, if you check here negative sine 60, which is basically it's a negative sine, if you go back here, which is basically this angle, which is if you want to measure this from here to here, this is basically 330 degree. So sine 240 and sine, it's not 330, it's 300 degree, because altogether it's 360. So basically sine 240 and sine 300 degree, they will give you the same value, which is negative sine 60, because this is 60 and this is again 60, and sine 240 is negative sine 60, and sine 300 also, it is also negative sine 60. So that's why uh, so the another angle for which the sine function has the same value as 240 is 300 degree. Okay, because sine 240 and sine 300 both they are equal to negative of sine 60, because 60 degree is your reference angle for both of them. Okay, we can use the same trick for the cosine 240, and as we can see here, cosine 240, the reference angle for cosine 240 is, it's as you can see here, it's 60, but cosine function on the third quadrant. Okay, so let me draw another graph here. 240 degree is this one, so the reference angle would be 60 degree, and this is on the quadrant 3. Cosine 240 degree is actually negative cosine 60 degree, but there is another angle, which is this one. If you can see, this is also 60 degree, and for this angle, this is, if you calculate from here to here, it is 120 degree. The cosine of, for 120 degree also, this 60 degree is a reference angle. Okay, and since we know from pi over 2 to 3 pi over 2 cosine function is negative, so this reference angle 60 degree is reference angle for both 240 and 120. So cosine 240 is also negative cosine 60 degree, and cosine 120 is also negative cosine 60 degree. So the meaning, both of them will give you the same value, which is negative half. That's why I can answer this question. The cosine as 240, we need to find out the same angle. Find an angle which gives you the same value for this angle, like this angle. So cosine 240 and cosine 120 degree, they both of them will give you the same value, same reference value, as you can see here, which is cosine 240 degree is equal to negative cosine 60, and cosine 120 is also negative cosine 60. That's why they are equal. Okay, you can always check that cosine 120 degree and cosine 240, both of them give you the same value. That's for problem 11. Let's go to problem 12. Find the coordinate of a point on a circle with radius 5. So for this one, so let's draw a circle here. Problem 12. Let's say this is a circle. Okay, find the coordinate of a point on a circle with radius 5 corresponding to an angle of 95 degrees. So 95 means somewhere here, because it should be greater than 90. So let's say this is 95. This is 95, and radius is 5. Radius is this one, radius. So we want to find out the x coordinate and y coordinate of this point. Okay, so if we draw a right angle triangle here, and let's say this is our theta, so we can always find the value of theta. If this is 95 degree, this angle would be 85 degree, right? because 85 plus 95 is 180. So if this is x coordinate and this is y coordinate, then this distance would be uh, it should be x, but make sure that it's negative. The value should be negative. So whatever x we're going to get here, we're going to use negative x, the negative of that value. So I'm going to borrow that triangle, right triangle here. This is 90 degree, this is 85 degree, and this is x. Whatever value of x I'm going to get, I will make it negative for that x coordinate. Don't forget that, because it's on the left side. And this is my y coordinate. So I just have to find, I just have to use this value here, and this is the radius. Okay, so I just have to use this right angle triangle and radius, which is what is the radius given here? The radius is 5. So the radius is 5. I'm going to use this 85 degree, 5, x and y, and find out the value of x and y. So by looking this right triangle, you can see that x over r is equal to cosine of 85 degree. You can see that cosine means base over hypotenuse. So base over hypotenuse gives me the cosine 85. So now if I solve this, the value of x would be radius times cosine of 85 degree. Okay, and that is radius is 5 times cosine of 85 degree. So if I use a cosine of 85, which is I'm going to use calculator here. So remember, this is in degree, so cosine 85 in degree times 5. So that is my uh, the x coordinate, but remember we have to make it negative. So if I use this one, it gives me 0.4357, and but that's just this length. We have to make it negative because it's going on the left side, so the x coordinate would be negative of this value. Okay, so x coordinate would be negative of that value, which is negative 0.4357. And we can do the same thing. We can use the same right angle triangle here to find the value of y. Y perpendicular over hypotenuse is equal to sine angle. So y equal radius times sine 85 degree. So which is basically 5 times sine 85 degree. So whatever value we're going to get here for the y, that's the value we're going to use there. But remember, this value is just a distance. We need the x coordinate, and this x coordinate is on the negative side. That's why we're making this negative. But for the y coordinate, we don't have to make it negative because it's a positive. So if you just multiply sine 85, which is let me just use my calculator, sine 85 times 5, which is 4.98. So I'm going to use that value here, 4.98. That's the y coordinate. So that's the x and y coordinate of this point for 95 degree angle and 5 degree radius. Okay, for problem from 13 to 20, from 30 to 20, you have to know some identities, relation between trig functions. So I'm going to give you a relation here. So first of all, you have to know this thing: sine square theta plus cosine square theta should be equal to 1. That's the one relation. So you have to know the relation between, cosine theta and secant theta, which is 1 over secant theta. Sine theta can be written as 1 over cosecant theta, and vice versa. You can do the same thing, like you can find out the secant theta equal 1 over cosine theta, cosecant theta equal 1 over sine theta. We need this relation. Tangent of theta is equal to sine theta over cosine theta, and cotangent of theta is equal to cosine theta over sine theta. These are the relation between the trig functions you have to know. Okay, I'm going to use this relation to solve the problems, most of the problems are here. So what is the secant theta if theta is 13 pi over 6? I don't know how to find the secant theta, but I know secant theta is equal to actually 1 over cosine theta by using this formula. So 1 over cosine 13 pi over 6. So you can use a calculator here. So if you try to find out the coterminal angle here, it would be 1 over cosine pi over 6, or just use the calculator and you can find out the value here. Cosine pi over 6 is square root of 3 over 2. So if you flip that, it will be 1 over square root of 3 over 2, and that will give you 2 over square root of 3. Okay, so here you don't have to write down the exact answer. You can just use 1 over cosine theta, 1 over cosine 13 pi over 6. Just use the calculator and it will give you the answer. Okay, and if you want in decimal form, the answer would be 1.1547. So by doing the same thing, I can, by using this formula here, cosecant theta is 1 over sine theta, and this is 1 over sine 13 pi over 6. I just use the calculator, and then value it gives me is 2. Okay, so tan theta means it's a sine theta over cosine theta. So you can use the calculator here. Sine 13 pi over 6 cosine 13 pi over 6. Use the calculator, and that will give you so sine theta is, it's 1 over 2, and then 2 over square root of 3. So basically it's a square of 1 over square root of 3. Or if you want in decimal form, you can use the decimal form as well. And cotangent theta is just a square root of 3. Just use the very same idea. Cotangent theta is cosine theta over sine theta, and use the calculator. Okay, so but the most important thing is you have to know this relation, this identities. Okay, and by using these identities you can do most of the problem here. What is secant theta? Secant theta is, one more time, it's 1 over cosine theta. It's a 1 over cosine negative 7 pi over 4. It's basically either you can use the calculator, or you can find the coterminal angle, and then that is actually cosine pi over 4, and that is actually 1 over square root of 2, and if you just simplify that, that will be square root of 2. So negative 7 pi over 4 and pi over 4, that's the same angle. That's why I'm just using pi over 4 here. We can do the same thing here. Cosecant theta means 1 over sine theta, and that is 1 over sine pi over 4, because negative 7 pi over 4 and pi over 4, that's the same angle, and basically it is also square root of 2. Tangent of theta is sine theta over cosine theta, so that would be 1 for this angle. Similarly, cotangent theta would be also 1. Just plug the value of sine pi over 4 over cosine pi over 4 for the first one, cosine pi over 4 over sine pi over 4 for the second one, and that will give you 1 and 1. Okay, for this problem 15 we should use this relation: cosine squared theta plus sine squared theta is equal to 1. So remember, the theta is in the fourth quadrant. So if theta is in the fourth quadrant, then cosine theta, the value of the cosine theta on the fourth quadrant would be fourth quadrant means it's the value of cosine function would be positive. So when you try to solve this squared thing, you have to use cosine theta equal the square root of 1 minus sine squared theta. You might have two different options, plus and minus, but because the theta is in the fourth quadrant, we just take the plus option here. So now cosine theta is 1 minus sine squared theta. As we know that sine theta is negative 2 over 7, if we just plug for the sine theta and then square it, it is 1 minus 4 over 49. And if we simplify this, just simplify this one, 49 over 49 minus 4 over 49, that gives us square root of 45 over 49, which is basically 0.95831. Okay, so that's how we can find the value of cosine theta, 0.95831. For the tangent theta, it's actually sine theta over cosine theta. So just plug the value of sine theta equal negative 2 over 7, and cosine theta, this one, it will be negative 0.2981. Secant theta means it's just 1 over cosine theta, so just divide 1 by this number, whatever you got here. So that will be 1.043498, 1.043498. Cosecant theta means 1 over sine theta, which is basically the reverse of negative 2 over 7, which is negative 7 over 2, which is negative 3.5. Cotangent theta is, it's just a reciprocal of tangent theta. So because it's cosine theta over sine theta, so the value would be negative 3.354. Okay, so basically you just have to use the trig identity to solve this problem as well. So let's go to next problem, problem 16. Problem 16. Simplify this trig function to a single trig function. So once again, you have to know the relation between the trig functions. So here, to simplify this, I am going to plug the value of cosine function, which is cosine means it's a cotangent, means it's a cosine over sine, and then cosecant means it's a 1 over sine, and there is a sine. So on the bottom part, you can make the same denominator by multiplying this term by sine t over sine t. We want to simplify that. So on the top there is a cosine t over sine t. On the bottom now it's a 1 minus sine square t over sine t. So now because it's a reciprocal over reciprocal, so you can just write down this as a cosine t over sine t times this sine t goes on the top, and this 1 minus sine square t comes on the bottom. So finally you can just cancel this sine t and this sine t, but remember 1 minus sine square t means it's a cosine square t. If you remember that relation between cosine and sine, if you go back on here, cosine square theta is equal to 1 minus sine square theta. I'm using the same fact here. 1 minus sine square theta is equal to cosine square theta. If I cancel one of them, it gives me 1 over cosine t, which is actually secant t. So for this problem, if you try to simplify and try to get one single trig function, that would be secant t. Okay, so that's problem 16. Problem 17 is easy one. Just plug the value of here, just plug the value of cosine t, cotangent t, which is cosine t over sine t, and this cosecant t means 1 over sine t, and basically it's a cosine t over sine t, and then on the denominator you have 1 over sine t. If you just flip it, it will be sine t over 1. So you can cancel this sine t and this sine t, and finally you are going to get cosine t. Okay, that's problem 17. For problem 18, you can do for the top one you just have cosine square t, and for the bottom one it's just 1 because sine square t plus cosine square t is 1. So it's already simplified, cosine square t. For number 19, you can change secant and secant to the cosecant, and let me write it down. 1 over cosine of t over 1 plus cosine of t. So on the top part I can write cosine of t over cosine of t to make the same denominator. So what I did is I just multiply this 1 by cosine of t over cosine of t, and on the bottom part we already have 1 plus cosine of t. Because we have the same denominator, on the top part I can write cosine of t, and on the top part that is cosine of t plus 1. But there is 1 plus cosine of t on the bottom part. This and this can be cancelled out. So the leftover would be 1 over cosine of t, which is basically secant t. Okay, so that's problem 19. Problem 20, secant t means 1 over cosine of t, and there is a cosine of t already, so we can just cancel this, and finally the simplification would be just 1. That's problem 20. Now let's go to problem 21. For the problem 21, we have given c equal 8, we have given a equals 70 degree. Now we want to find out a, b, and b. Now as you can see, this triangle, this is 90 degree because it's a right angle triangle. This is 70 degree. Sum of these three angles should be 180. So that's why if you subtract 180 minus 90 minus 70, the value of b would be 20 degree. It's a 20 degree. And for finding a and b, as you can see, a over c equal, you can write a over c means perpendicular over hypotenuse is sine 70 degree. So if you want to find a, that is c times sine 70 degree, and c is basically 8 here, so it's 8 times sine 70 degree. If you multiply these two, 8 times 70 degree sine 70 degree, that will give you 7.51 for a. If we do the same thing, b over c base over hypotenuse, it is actually cosine function, cosine 70 degree. So base is c times cosine 70 degree, which is 8 times cosine 70 degree. If I use my calculator, it will be 2.74. So that's problem 21. Let's go to the very last problem, problem 22. The angle of elevation to the top of a building in Newark is found to be 5 degrees from the ground. So let me try to make a picture here. Let's say there is a building. This is the building, and this is the ground here. Angle of elevation means here is the angle, and that angle is 5 degrees. So this angle is 5 degrees, and the distance from the ground to this point is 2 miles. Since we're looking for the height of the building, and the height of the building, it would be easier to measure in a foot. So this 2 miles also can be written in terms of feet. We know that 1 mile is 5,280 feet. 1 mile is 5,280 foot. So we can multiply this by 2. So it is 5,280 times 2 feet. So now we know this is the 5 degree, this is base, and we need to find out the perpendicular. So base perpendicular over base, perpendicular over base is actually tangent of this angle. In this case it's a 5 degree, and perpendicular is actually the height of the building. Perpendicular is height of the building we're looking for, and base is it's 2 times 5,280, and this is tangent 5 degree. So if you want to find out the height of that building, then you just have to multiply both sides by 2 times 5,280. So height of the building is equal to 2 times 5,280 times tan 5 degree. If you use your calculator, this value would be 923.88 foot. So that would be the height of this building. This is the answer. 923.88 foot. So for this particular problem, you just have to know perpendicular over base is equal to tangent of this angle, and you also have to convert the miles into the foot, and then you will be fine. So these are 22 problems from exam to review. So just do these problems, and then after that, if you still have questions, feel free to email me. Okay.